The rule that I introduced you to in the last video is called the power rule. The reason why it's called the power rule is because it concentrates on the exponent of the variable x. We're going to use this power rule once again in this example. Now you can see straight away that I told you had to have all your variables in the numerator, and there's an x squared in my denominator. As that's a common denominator, it actually belongs under every single one of those terms in the numerator. So before I find my derivative, I'm actually going to write this so that I can recognize what this could be if I could get all my x's into the numerator. So f of x over here could in fact have been written as 2 all over x squared minus x all over x squared, and then plus 3x squared all over x squared. Simplifying this expression for f of x, I find that I've got 2 all over x squared minus 1 all over x, and then plus 3. Well, this doesn't seem as though I've got very far because I still have x's in my denominator. But as that x is a factor and the numerator is also just a simple factor, I'm able to take those x factors up to each numerator. In other words, fully simplified and in standard form, the first term is going to be 2x to the minus 2, and then minus x to the minus 1, and I leave the 3 where it was in the numerator. You can see now that I've got my function so it goes term, 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 and all the variables are in the numerator. At this point only am I ready to use my power rule to find the derivative. So using the derivative, f prime of x is going to be equal to the following. Now I'm going to do this in 2 steps. Eventually you'll get very good at it and you'll be able to do it in your head. 2 was a coefficient. The exponent of x goes down as a coefficient factor. Write down your variable with its original exponent and then minus 1. Minus 1 was a coefficient of the second term. Minus 1, the exponent of x, becomes a coefficient factor. Write down your variable with its original exponent and then minus 1. Now what would this actually have been for 3? I told you that the derivative of a constant is 0. But let me show you exactly how this would work using the power rule. If I've got 3, I've got 3 times 1. And 1 means I've got any factor to the 0. And you can see by writing this down, if I used the same method that I'd used in term 1 and term 2, I would have written 3 as my current coefficient, times by 0, which is my exponent of x, which becomes a coefficient factor, times by x to 0 minus 1. Well, anything times by 0 is 0, and that is how, using the power rule, I know that my last term is going to be a 0. So still, the derivative of a constant will always be 0. All that it remains for me to do now is just to simplify my terms. So the derivative of f of x is going to be minus 4 times by x to the minus 3 in the numerator, so that means it's x to the 3 plus 3 in the denominator. Minus 1 times minus 1 is plus 1, and that's times by x to the minus 2 in the numerator, so that must be x squared in the denominator. And my last term is 0. So we've found the derivative of f of x using the power rule. In this example, we have a great problem because I've got a bracket squared. In other words, my information has not been broken down to term, term, term. In order for me to be able to find the derivative of this function, I cannot use the power rule until my information is given to me in terms. As this bracket was squared, it's not too difficult for me to multiply it out. And when I do that, you must remember that this is going to be x cubed minus 2x times by itself. Then what you need to do is multiply out your brackets to find out what this would be as a simplified expression. In other words, it would be the expression of x to the 6 minus 4 x to the 4 plus 4 x squared. As by multiplying out, I already have all my information in the numerator and I have terms without brackets, I'm able to find my derivative. Now remember, this was a different notation, and so I must stay with the same notation. You might be interested at this stage to know that this notation is called Leibniz's notation or Leibniz notation. In other words, if I want to find the derivative, I say the derivative of the function y in the important variable x is going to be the following. Using the power rule, 6 becomes a coefficient factor, so I've got 1 times 6, which is 6. Write down your variable and take 1 away from the original exponent. 6 minus 1 is 5. Minus 4 was a coefficient, and the exponent 4 becomes a coefficient factor. Minus 4 times 4 is minus 16. Write down your variable and take 1 away from its original exponent. And then lastly, 4 times 2 is 8. And then take 1 away from the original exponent of x, which is x to the 1. So the derivative of that original function is given to me by 6x to the 5 minus 16x cubed plus 8x.